So in this problem we have a portfolio analysis. It tells us we have the means and standard deviations for annual returns from 3 different funds for the last 10 years. And we're assuming that each fund is independent from the others. So we have 3 different funds W, X, Y. We have their means and standard deviations. Now we can write means and standard deviations with that notation. You could also write it with the notation expected value of W equals 10.12 and standard deviation of W equals 17.46. Now notice the percents on here. These percents do not matter. That is just the unit. So sometimes we have to worry about percentages, but that in this case is just the unit. It's just like saying inches or feet after the number, so we're not going to worry about it at all. Assume that a portfolio contains 70% grade bond fund X and 30% Y stocks. Calculate the mean and standard deviations for the returns for this specific portfolio. So our portfolio, let's call it P, is going to be equal to 70% X. So 70%, I'll change that to decimal because that actually is the percentage and not just the unit. We're going to do 0.7 of the W stock, X stock. Okay, I'll start over. I forget I can't erase when I copy something. So my new random variable P is equal to 70% or 0.70 times X plus 30% or 0.30 times Y. We want to find the new mean and standard deviation. So this is what we did in our chapter where we talked about the rules for combinations for random variables. So we're looking for the expected value of P, or in our case, the expected value of 0.7x plus 0.3y. So when you do expected value rules, 0.7 times x can just come out of the expected value. So we'll do 0.7 expected value of x. And the nice thing about adds is they just kind of come out. So we'll just do the expected value of each one individually. So then we'll do 0.3 times the expected value of y. So the numbers get to come out and we add each thing separately. So this is going to be 0.7 times the expected value of x, which is 6.46, plus 0.3 times the expected value of y, which is 11.1. And I didn't bring my calculator in, so you can put that on in your calculator on your own. Now, we can't go straight to standard deviation. Instead of standard deviation, you have to do variances first, and then you can get back to standard deviation. So my variance is going to be the variance of this 0.7x plus 0.3y. Now, when you do variances, the add is still easy. You just do each part individually. But this 0.7 to come out, any number that comes out of a variance has to be squared. So we're going to do 0.7 times the variance of x plus 0.3 times the variance of y. So 0.7, now I didn't find the variance of x. So if the standard deviation is 4.18, then the variance of x is going to be 4.18 squared. And the variance of y is going to be 15.62 squared. So 0.7 times variance of x is 0.7 times 4.18 squared plus, now this, oh sorry, I didn't actually do that, did I? When the 0.7 comes out, it gets squared. I wrote it here, but I didn't write it here. And when the 0.3 comes out, it gets squared. So 0.7 squared times 4.18 squared plus 0.3 squared times 15.62 squared. Okay, put that in your calculator and it's going to give you whatever the answer is. Now for the standard deviation of P, or if you want to use the notation standard deviation of P, that's just going to be the square root of whatever you got for your variance. Again, sorry I didn't bring my calculator in. So square root of your variance gives you whatever your final answer is.